Hi friends, welcome to Unacademy, India's largest learning and teaching platform. I'm Bhavani and we have been conducting mock tests on YouTube. So as you all know, Unacademy offers plus courses for Karnataka CET students who want to excel in CET exam in the year 2021 can subscribe the plus courses. When you subscribe a plus course, you will have both class 11 and class 12 topics that will be done in detail. All the essential points, the necessary tips and tricks will be shared during these sessions. You will be also given daily practice paper, also given full-length mock tests with analysis, and number of batches you have. A lot of educators and plenty of classes. All these are happening under the same platform, that is Unacademy. And students, for single subscription you have unlimited access. So students who want to excel in CET exam in the coming year, that is 2021, you can subscribe the plus courses. While subscribing the plus courses, kindly make use of the code BHAVANILIVE and get the discount. We have different plans. There is a 12-month plan at the rate of 12,375. We have a 6-month plan at the rate of 10,125. We have, whichever is suitable for you, you can join those batches. You have a comprehensive batch where the syllabus will be covered in 8 months. You have a 6-month batch where, the topic will be done in Kannada. So those who are comfortable with Kannada, you can join these batches. You also have a champions batch and it has started from 15th of October. So in case if you are interested, you can join this batch, okay? You can be a part of this batch. There are different combinations available, PCM, PCMB and PCB. So you can enroll your name. You can make use of the code BHAVANILIVE and join these batches also. The free practice test for the CET exam has started from 2nd of November. In case if you are interested, you can enroll your name and you can attempt it live and try to crack the CET with a better ranking. Students, in case if you haven't watched my classes, if you haven't watched my previous YouTube classes, kindly watch them. You subscribe the YouTube channel and watch these classes and see to it that you are sharing the videos among your friends. In case you like the classes, kindly press the like button and also press the bell icon so that you get a notification. You can even go for a description box and get the necessary links, okay? Under Unacademy also, I have taken a number of free special classes. So you can watch all those free special classes, okay? So my next YouTube session will be on 10th, exactly 2 o'clock. So do not forget to watch that class also. And if you missed any of the classes, kindly watch them and see to it that you are informing your friends also, okay? So we will come with the, we'll start with today's topic and we will go with the first question. So you can go through the question, student, and you can tell me the answer, the possible answer for the question. As you can see, students, there, question number 1, pressure remaining constant. At what temperature the volume of given mass of gas will be twice its volume at 0 degrees Celsius? So the condition given here is pressure is constant, okay? Pressure is constant. And you can see the question, at what temperature? So temperature is asked. At what temperature the volume of a given mass of gas will be twice its volume at 0 degrees Celsius? Students, pressure is constant temperature and volume are related. This is nothing but Charles' law, isn't it? So according to Charles' law, you know, when pressure is constant, volume is directly proportional to temperature, isn't it? So the initial temperature is given as 0 degrees Celsius, isn't it? Right? So they are asking at what temperature the volume of a given mass of gas will be twice. So according to this, as the volume increases, the temperature also increases. Or in other words, as the volume doubles or as the temperature doubles, the volume also doubles. So the temperature is given as 0 degrees Celsius. That is nothing but 273 Kelvin. Okay, 273 Kelvin. So temperature doubles. Okay. When a volume of a given, say at what temperature, volume of a given mass of gas will be twice. So if the volume should be twice, then the temperature need to be doubled. So temperature is doubled means, it means temperature doubled. That means the temperature is 2 times of this. That is nothing but 2 3s are 6, 2 7s are 14 and 546 Kelvin. So at 546 Kelvin, the temperature, the volume of a gas also doubles, isn't it, student? Therefore, 546 Kelvin, what is, how do you convert in degrees Celsius? You know, Kelvin is equal to degrees Celsius plus 273. So if you are saying 546 Kelvin, then the degree Celsius also should be 273, isn't it? 273 degrees Celsius. So our answer will be option B, that is 273 degrees Celsius. I hope you have understood the question, student. We can go to question number 2. Let us go to question number 2. Nitrogen is found in a liter flask under 100 kilopascal pressure. Under 100 kilopascal pressure. And oxygen is found in another 3 liter flask of under 320 kilopascal pressure. If the two flasks are connected, the resultant pressure is option A 210 kilopascal, B 220 kilopascal, option C 420 kilopascal and option D 265 kilopascal. Okay, so students, how do you find the answer? You can try answering for this question. The resultant pressure is asked. You are mixing two gases and you want to know what is the total pressure. So according to Dalton's law, you know that the total pressure is nothing but partial individual gases. That means partial pressure of nitrogen plus partial pressure of oxygen. How do you calculate the partial pressure? Partial pressure is nothing but mole fraction, right? Mole fraction. Now since it is gases, I can take it as volume fraction, a volume component, or it is volume fraction, isn't it? Into the total, the mole fraction into total pressure. Okay, into total pressure. So mole fraction is total volume. You have taken a liter, 1 liter of flask, so volume is 1 liter and here it is 3 liter. So total volume is 4, out of which nitrogen is 1 liter. So this is a mole fraction into its pressure is 100 kilopascal. When nitrogen alone is taken in a flask, its pressure is 100 kilopascal. right? That means it is nothing but you are going to get 25 kilopascal, isn't it? So partial pressure of nitrogen is 25 kilopascal. Similarly, partial pressure of oxygen. Now when I say partial pressure of oxygen, student, mole fraction, so total volume is 4, out of which oxygen is 3, and the pressure is given as 320. You can see here the pressure here is 320 kilopascal, isn't it? Therefore this will be 480, this will come as 240 kilopascal pressure. So sum of this will give you the total pressure. So 265 kilopascal. Answer will be option D. So for the second question you have option number D. Let us go to question number 3. A catalyst may alter at the end of a reaction regarding. This is a simple question. When a catalyst is involved in a reaction, will the physical state alter? Will its chemical composition changes? Or does it both the physical state and the chemical composition changes? Or none of these factors changes? Students, we know that whenever a catalyst is involved in a reaction, the chemical composition remains the same even at the end of the reaction. However, its physical state might change. Therefore, the only factor which is going to be altered will be option A, and that is physical state. So, we'll go to question number 4. The alkene producing CHO, CH2 4 times CHO on ozonolysis is option A hexene 1, option B hexene 3, option C cyclohexene, and option D 1-methyl cyclohexene 1. Students, what can be the right answer? So among the 4 options, which alkene on ozonolysis give this product? Students, whenever it is ozonolysis, whatever may be the question, but the answer will be very, very simple, student. It becomes, very easy to answer. In this ozonolysis reaction, product is given. You can see the product. The reactant is asked, which is that alkene which is giving this product. Now, how do we arrive at the answer? You need not write the reaction. I'll tell you a technique. You have to follow that technique for any reaction, student, for any ozonolysis reaction. You just write like this. Let me write once again. Okay. You have to remove the oxygen and you have to connect to those 2 carbon atoms and draw a double bond between those 2 atoms. See now, you have 4 carbon atoms, you have 5 and you have 6. Agree, student? Therefore, 1, 2, 3, 4, 5, 6. And between any 2 carbon atoms, see these are the 2 carbon atoms, they are joining. You need to draw double bond. And what is this, student? This is nothing but hexene or hex. It can be called as 1-hexene or hex 1-ene. Okay, so the answer will be, student, as you can see, your answer is option A. So have you understood, student? Is it clear to you now? Is it clear? See, for example, if a alkene is given and if they ask you for ozonolysis, I'll tell you how to predict. You break this double bond, add O on both the sides. If Product is given and alkene is asked. Remove oxygen and add those carbon atom by a double bond. See, when you break this carbon is having now CH, isn't it? So it becomes CHO. You look here, this becomes CHO. Alright, then CH2, 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 CH2. How many times? 4 times. CH2 4 and then once again CHO. So ozonolysis is a very simple reaction to predict. Like in the classroom, do not spend too much time on writing. Simply predict the product. If a question is like, CH3, CH, double bond, CH2. How to predict, student? Can you tell me based on the same technique, the technique what I have given, can you tell me the product? I have taken propene. So can you tell me what do you get? What you are supposed to do, students? You need to break the double bond, break it, add oxygen on both the side. So one of the product is CH3CHO and the other product is HCHO. So prediction becomes very, very simple. This is given and if the reactant is asked, remove oxygen, add double bond CH3CH, double bond CH2. You get this one. I hope it is clear, students. I hope you are understanding. Okay, is it clear? Okay, go to the next one now. Which compound answers iodoform test? Option A is methanol. Option B is benzyl alcohol. Option C is, what is it now? C6H5COCS3. It is acetophenone and none of these. Students, you are given 4 options. Question is, which one is iodoform test? In the competitive level exam, iodoform test is an important test. This part is, likely to appear somewhere or the other in the organic chemistry, or I can say one of the essential part you should be knowing. So that is iodoform test. So can you tell me, student, what is the right answer? Is it option A? Is it option B? Is it option C or is it D? So can you tell me the answer? Iodoform test. Iodoform test is answered by methyl ketones. Important observation, you need to know this one. Methyl ketone means CH3C double bond O. Organic compound which possess CH3CO group answers iodoform test. But it is also answered by some of the alcohols. Alcohols like maybe isopropyl alcohol or maybe ethanol, because these alcohol on oxidation, what happens on oxidation? H2 is removed and you have CH3COCH3. This contains CH3CO group, right? Therefore, iodoform test is answered by all the methyl ketones and all those alcohols which on oxidation gives the methyl ketone, the CH3CO group. I hope I am making it clear. What is iodoform test? In this reaction, the methyl ketones or any of these compound will react with sodium hydroxide and iodine. Now instead of this, they can give like this, NaOI, sodium hypoiodide. Then you get iodoform, yellow crystals of iodoform. yellow crystals of iodoform is formed, which is an indication that the compound contains CH3CO group. Okay, so look at the example now and tell me which one can be the right answer. Is it A, is it B, is it C, is it D? Which is the right answer, student? This one, acetophenone. You can see, if you want, I can write C6H5 like this. C double bond O CH3. So you can see here this contains CH3CO group, answers iodoform reaction. Okay, so this is the also known as, this compound is acetophenone, or you can have phenyl ethanone, 2 carbon atom. So phenyl ethanone can be the in naming also, if you're going for IUPAC name. Alright students, so go to question number 6 now and look at the question. Aqueous solution of amino acids are they acidic, are they basic, are they alkaline, or are they amphoteric? In aqueous solution, if you take amino acid, student, amino acid is RCH NH2 COOH. This is amino acid. Amino acid in solution will behave like amino and acid group. That is why the name amino acid. Okay. Now students, look here. You have here in aqueous solution the acidic part, the COH part, donates a proton, and the nitrogen, the lone pair, abstract this proton. So you have RCHNH3 plus and you have COO minus. So this is a Zwitter ion structure. It is neutral, okay, neutral because it has both positive and a negative charge. This is neutral. But then a Zwitter ion can act like an acid. It can accept, for example, H plus ion. It can accept H plus ion and it can form RCHNH3 plus and COOH. Okay, so it can act like a base. So okay, is it only for you or other students also? Can you tell me? My voice is breaking. Students, those are watching my class, am I audible? Okay, then I think Shamant, you need to slightly look into your network. Anyway, similarly, the Zwitter ion can also react with a base. A Zwitter ion can also donate a proton. This NH3 can, you cannot hear? Am I audible now? Students, am I audible now? Am I audible? No? Students, am I audible now? Students, I hope you can hear me now. Yes. Okay, so in case if error comes, you tell me. Now look here student, this Zwitter ion can accept a proton and form this one. It can lose a proton, this NH3 plus can lose a proton. When it loses a proton, it will form RCH. You can see here, it will lose a proton, NH2 and COO minus. So Zwitter ion can act like an acid, donate a proton. It can accept H plus ion, behave like a base. That means it is amphoteric in nature. Option D is the right answer. Now go through the question. I want you to answer the question, student. Meanwhile, I hope I am audible now. There is no problem with the voice. Students, everyone, can you hear now? Am I audible? Because since you have said, am I audible? I hope I'm audible. That's why I think no one is. Okay. We will go with the question now. Germanium is an example of. Option A, intrinsic semiconductor. Option B, extrinsic semiconductor. Option C, an insulator. And option D, an N-type semiconductor. Students, can you give me the answer? Is it option A, option B, or option C, or tell me germanium is an example for? What is your answer? When such question is asked, you should be able to give the answer as quickly as possible. What is the right answer, students? Germanium is an example for intrinsic semiconductor. Germanium is undoped conductivity. When I say extrinsic semiconductors, the conductivity is due to the impurities which are doped. Extrinsic means externally you are doping some impurities. Whereas when I say intrinsic semiconductivity, it is due to undoped condition. That means it depends only on the number of holes and the electrons, isn't it? Germanium silicon is an example for intrinsic semiconductor. When you dope it with some impurities like phosphorus, arsenic, then it becomes extrinsic semiconductor. Okay? Alright, go to the next question now, students. 1 mole of PCl5 dissociated to an extent of 25% when heated in a closed vessel in 250 degrees Celsius. If in the same vessel 4 moles of PCl5 are taken, then approximate value of percentage. Students, kindly read the question and try to find out the answer. Meanwhile, let me also try to solve and tell you how we can solve this question. You know, PCl5 is dissociated as PCl3 and Cl2. The dissociation is in 100, it is 25, it's given 25%, but 1 mole of PCl5 is taken, so the dissociation will be, student, 0.25, isn't it? 0.25. Now you can see initially the number of moles of PCl5 taken is 1 and the PCl3 are 0. Number of moles dissociating is 0.25, it has been given. you get 0.25 mole of PCl3 and 0.25 mole of Cl2. So after the dissociation, remaining is 1 minus 0.25 PCl5 and 0.25 PCl3 and 0.25 Cl2. So this will be 0.75. Based on this, we can have Kc is equal to PCl3 molar concentration into molar concentration of Cl2 divided by molar concentration of PCl5. So if you solve this one, you will get 0.25 into 0.25 divided by 0.75. So find out, students, kindly solve and find out what is the answer you will be getting. You will get 0.0833. This is the answer. This is the Kc value you are going to get, isn't it? But you are not asked Kc value. You are not asked equilibrium constant. You are asked a percentage dissociation condition now, 4 moles of PCl5. So look here now, PCl5 giving PCl3 plus Cl2. We have taken the degree of dissociation is not said. Therefore, let us consider that for 1 mole it is X. So 4 mole it will be 4x. So 4x mole of PCl3, 4x mole of Cl2. So this will be 4 into 1 minus x remaining. So if you want to calculate Kc, you know PCl3 is 4x, Cl2 is 4x, and this will be 4 into 1 minus x, isn't it? So Kc is nothing but, you can see there, 4x square. 1 minus x is taken as 1, considering that x is very, very small. We know the Kc value. Kc value is 0.0833. That is 4x square. Therefore, x square is equal to, how much it will be? 0.02, somewhere around 0.8. So x is asked, so you have to see the square root. So you know you have to take now consideration now. See how much it can be. 0.02 you should get. That means it cannot be 0.1, 0.1. It can be maybe 0.1 some alphabet, maybe 0.1413 like that, isn't it? So this is x, but we want it in percentage. That means somewhere in 14%, 15%, something like that. Since answer closer is A, answer A, option A will be the right answer. So students, thank you for attending the class. As we have come to the end of this session, kindly remember that next class will be on 10th and exactly at 2 o'clock, a half an hour session. You can attend these classes. So in case if you have liked today's class, do not forget to share the videos among your friends. So bye bye students. Let us see once again on 10th exactly at 2 o'clock. Bye students.